have the Power Query side, which is Power Query optimization. We have the report view optimization, the DAX optimization, and then the data model optimization. Some of us make use of text feed and a text feed from here. Let me say customer name. There's a customer name here, customer name in another tab, and you're linking it on that customer name. It's not advisable to be using that kind of text key. But the best is to use a numeric key. That's why we have customer ID. When you go to the hospital and they take your blood, they take this, they take that, they tend to tell you that this is what is happening in your body system. Same thing with the Vertipack analyzer. It just tells you the health performance of your data model. If you ensure that all these things are taken care of in your data, from Power Query to your data view, then you are good to go. Today we're going to be looking at how we can optimize our reports and then to ensure that there is efficient reports out there for users. You know, sometimes even if you're looking some websites and you click on something on a website and it's so slow, you see that you're so frustrated and you feel like, oh, I cannot just go to this website again. I don't want to make use of it again because that website is not efficient. Same thing with all our reports that are taking time to load like that. Your users will always complain that this report is not efficient for them and they might well just drop the report and not use. And that's not what we want as a data analyst. So we have a lot of challenges like business intelligence value, scale challenges. Our data grows every day. We are not having a stagnant data, right? It's not all this data that you just get online. This is business data, so it grows every day and every second. Majorly, even if you're having real-time data, that's another big data thing. So also we have resource constraints, and all these challenges actually pose threats on our users and even us that we are building it, slowing down our work, which is not efficient. So majorly, we have 4 key areas we're going to be discussing today for Power BI solutions, efficiency, and optimization. So we have the Power Query. So in different areas that you can optimize your report, we have the Power Query side, which is Power Query optimization. We have the report view optimization, the DAX optimization, and then the data model optimization. Although there might still be one other aspect that we might not touch, but the major 4 key areas that we're going to be touching today is Power Query, report, DAX, and then data model optimization. So I would just want us to talk through this content first before going to Power BI to see what exactly that we've discussed here and then make use of it in the report and see how we can optimize it. So for Power Query optimization, a lot of us, we use Power Query, it's an ETL tool, right? And then we get our data set from the source and then we transform it, clean it, do a lot of stuff in Power Query. But also that Power Query needs to be optimized in one way or the other. It's not just adding a lot of apply step, and some apply step would be like 50, 60, and the likes. So there are still ways that we can optimize our Power Query to just ensure that it's not taking time from Power Query session. So for the first one says amend data and column types. Majorly when we get data set from the data source, we have different data types. Some are integer, some are decimal, some are dates, some are date and time, like that, and the likes. And when we load them back to Power Query, we also have privilege of changing the data types. However, there are some data types that can impede our performance, especially date time. So if you're having date time together in a column, I have maybe receipt date or what's it called, start date or anything date, and you're seeing date and time all together joined inside, right? It tends to increase your data size. And because of that, it might take time. So that's the first thing, which is the dates and column types that we have in Power Query. We need to ensure that we're using the right data, the right data types for our data. Sometimes, even columns, this date and time, you can separate it into 2. You have date separately, you have time separately. So it will create this large size data model for you. And then also database normalization. For this, we have a big flat files, right? And we need to break it down into several tables. So you have facts table, you're generating facts table from it, and then other dimension tables from it, so that you can link them up in your data model to ensure efficiency. However, you're not having just one big table and you're still making use of it like that, right? You're not separating up, how do I say it? Like transforming your big flat file into various tables. It's the most efficient way. But if you're having it in just one table, it's not efficient enough. So the best is for us to just break it down and have a normalization in our data. Then also imported columns versus calculated columns. For this, number one, we get data source from we get our data set from our data source, be it SQL, Excel, CSV files, or Snowflakes and the likes. But it is better for us to get those columns from the data source rather than creating extra columns. However, there are some scenario that you do not have a choice than just to create columns. But if those columns are the column that you can push back to the main source, that is, you probably just want to get segment of a particular product, and it's something you can use case when in your SQL, it's better you do it there than make your view, as in bringing your view into the model, rather than creating that column and saying, okay, if this is this in your Power Query, or calculated column saying, if this one is equal to this, then give me this. If something you can push back to the source, it is best for us to push it back to the source, not to increase our data model. I don't know if you are getting it. Then, I will not talk too much on everything because of our time too. I will just pick one or two things and then discuss it. Others we can read up on it. I can actually give the PowerPoint and then we can read up on it. Disable load, there is something we call helper table, helper data in Power Query. You know, when you bring in a data set, and this data set is just loading product table alone, or let me say it's loading a particular case manager's name, or let me say it's bringing only names of people, right? And you want to use that table to get something else. Like probably you want to join it with another table to bring in something from that table. This table, if you do not need it in your report view, there is no need for us to load it to the report view. But most of us, we don't even check through it. I have like 10 tables, and I'm only using 5 of these tables in my report view. There's no reason bringing the other 5 to the report view. So you just disable it. Then also, there are some that you might need it, right, in your data, in your report view, but you do not need to refresh it every time, because when you when you refresh a report, it blows in all the table afresh, right? But in some cases, you do not need a specific table, because it's not that it's refreshing from the data source. It might be stagnant for a whole 1 year and nothing is changing there. So there is no need for you to refresh that particular table. So you just exclude it from refresh from the Power Query session. So when it is loading to your Power BI, it will load that data afresh. So it will reduce the time it takes your reports to refresh most of the time. So, and then for the data model of optimization, so for here, it is advisable that we use star schema most of the times than using Snowflakes. Though I've used Snowflakes before several times. However, if I'm using Snowflakes, then I have to ensure that this data model is best optimized, because it is not well advisable. So I hope we know the difference between the Snowflakes and then the star. So it is best for us to use the star schema rather than using the Snowflakes one. And then many-to-many relationship, there are a lot of tables that we have many, then many these, combining them together, and even saying, okay, I want both to be linking together, what's it called? So all this many-to-many relationship is not advisable. Most of the times we can normalize it. There is a many table, there is another many table. I'm sure one of the many table, it's something that you can see normalize and create and bring it down to 2 other tables and then make it a star schema, which is best. Then data, using, this numeric key for relationship is also important. Most of us, when we are linking our data model together in data model view, some of us make use of text feed and a text feed from here. Let me say customer name. There's a customer name here, customer name in another table, and you're linking it on that customer name. It's not advisable to be using that kind of text key. But the best is to use a numeric key. That's why we have customer ID, sales, what was it called? Product ID, this one ID, that one ID. So it's best for us to use those kind of numeric, because it quickly checks through the numeric ID against the other table and then load in your data rather than using the text, text keys for our relationships. Then there are some row level logic in our Power BI, like all these row context, and that will be checking through row by row, calculating things row by row like that. If it's something you can do in Power Query, move it back to Power Query. You know, we create in our DAX, in our table view, right? We create measures and say, okay, some hex or multiply this by this, like that. So all those things, if you move it to Power Query, it's more efficient than doing that in Power BI, because the Power Query won't take too much of size compared to the Power BI data modules aspect. And then for the DAX optimization, we all use DAX measures, calculated measures, this one measures and the likes, which is very, very good. And when doing all these DAX, you know, some of us will just complicate matters and write a long DAX measures that you yourself, you'll not even be able to understand later on. You open the report and be like, let me try to understand this DAX. But if you can simplify all those DAX measures and your expressions, you know, some of us just write DAX measures as if we are writing text, or we are writing, what do they say? What do they call this? You are writing content, or you are writing something on LinkedIn like that, which is, no. It's actually a bad one. You know how we write, our developers, how they write their code. If they are writing it as for you as text, long, not even a space, not even a break, like that, how would you feel? You will not be able to comprehend what they are saying. So that it is also best for us when we are writing our DAX measures, simplify it, right? In some cases, we use variables. If you want to write like a lot of measures, calculate if this is equal to this and that and that and that, you can break it down and use variables. Like variable A is equal to this. You can call that variable A in another variable B. You can call that variable B in another variable C, and like that. So simplifying it will help you when you're hoping your report later on to even make some adjustment and some changes to it. It just helps you to understand it better and then to clarify, then just give you right and correct, solutions to that kind of formulas. Then measures and calculated columns. We calculate, measures doesn't add to our data module size, but calculated columns add to it and make it even larger. So in some cases, if it is very important for us to create calculated columns, push it back to where Power Query. Else, make it a measure that won't add to our module size most of the time. Then we make use of calculated tables, right? Calculated table is very, very important. However, when we are making use of calculated tables, like I want to have, date or calendar table, right? You know, we say calendar is equal to calendar auto, or specifying your time and then your start and your end date, which is good. However, when we are done creating that calendar table, it is important for us to mark it as a date table. Because if you don't mark it as a date table, in your behind the scene of Power BI, it will be looking at each date column that is seen everywhere. It will be loading it as this table. That's why when you open DAX Studio or Tabular Editor to see the health status of your data module, sometimes you see a lot of data table, because it's seen a lot of date feed everywhere, recognizing that date table. So when you have that calendar table, you mark it as what? As date table. So for the report view aspect, we create beautiful visuals, right? Nice visuals, and have a lot of slicers there, filters by the right side, filters by the left side. Yes, they are good. However, minimization is important. In everything, say minimize how you do your stuff. It's because it can cause a lot of damage, or a lot of damage to your report and your refresh. So you have some report pages that you're having like 10, 12 visuals in one. It looks beautiful to you, right? But in essence, in business, you don't need to bombard your face with that lot of visuals. You can break it down into different pages, which is even more efficient for them. But if you're making it like 10, 12 visuals inside one page, and you have slicers, a lot of slicers, a lot of filters, no matter what, even if you click on one filter or one slicer, it will slow down. That one is normal. It will slow down. So we have to minimize our visuals. Then the difference between drop-down and list slicers. So for drop-down slicers actually increase your data, it increase your report size. Let me put that storage size. It increases it compared to drop down. You know, drop down is just you click all, then you can see everything at once. But list, it's already listed for you. So anytime you're refreshing that report, it takes time because list slicer use more space than the drop-down slicer. So just take it at the back of your mind that anytime you're building your report and you're adding slicers to it, ensure to make use of drop-down the most compared to list slicer. Though sometimes that list slicer looks beautiful to us and we want them to see everything at once, but we can still try to. But though if your data size is not large, fine and good, you can use list slicer. That is why we also try to check our metrics or check the overall metrics of all our reports inside DAX Studio or Tabular Editor. Then it helps you to know that, okay, this is large, this is not large. Let me make use of list slicer, let me make use of drop-down slicers. Then visual interactions too. I don't know if anyone do click on that visual interaction, edit interactions, and then you try to edit a lot of interactions amongst you. And even some even went back again to go and be reclicking cards. So if you're having card slicer, card visual, you still try to, okay, I want this to filter that. So there are some cases that you really do not need some visual to be affecting another visual. Just try to minimize that kind of visual interaction between all the visuals that you're having on the report. Then it is advisable we use drill through sometimes. When instead of putting a lot of information on a particular page, you can use drill through, then click on the drill through, it takes you to another page, or rather still use bookmarks. So for bookmarks, you click on a particular bookmark, you see whatever you want to do. You click on another one, you see what you want to see from there, rather than just bombarding like 10, 12, 15 visuals on one page like that. Then we'll be looking at this performance analyzer, which it's a major part of importance in Power BI. We have VertiPack Analyzer, we have Performance Analyzer, and these are two different things. They are not the same thing, so we should not try to mix them up together. So for Performance Analyzer, it's a built-in tool in Power BI. It's something you can just go to Power BI, click on it, then you try to record. You record your session. Maybe you want to record how much time or how much seconds, how much minutes is taking this visual to load, how much time is taking this slicer or filters. If I click on this filter, how much seconds will it take for those visuals interactions to load and things like that. So you just track how your visuals are loading. It tracks your DAX measures, all the complex DAX measures that you've created. It checks it through it and then see the time that it's taking those DAX measures to load. And then it's just, in general, if you are having a lot of visuals and the likes that we've discussed earlier, it slows down your reports. And that is why you use Performance Analyzer. At the end of a report, it's very important as a data analyst. You just go through your Performance Analyzer first before publishing it to the service itself. Let me see what is going on in my report, because if users are using it, how do I want them to interact with this report? So when you see how many minutes it's taking, you yourself, you know that, okay, it's time for me to optimize this report. It is time for me to optimize, be it Power Query side, DAX, report view, or the other one. While for VertiPack Analyzer is just as all of us who go to the hospital, right, to check our health status, to see, okay, how am I faring? You cannot see it from outside, but when you go to the hospital and they take your blood, they take this, they take that, they tend to tell you that this is what is happening in your body system. Same thing with the VertiPack Analyzer. It just tells you the health performance of your data model. You know, here we're talking about your visuals, your interactions, and the like. But in VertiPack, we're talking about the data model size as a whole. So you check the health status of your data model, the data type. Is the data type correct? Are you supposed to use decimal when you're using this? Are you supposed to use date when you're using date and time? Are you supposed to use this instead of this? So it just tells you that. Then it tells you your table sizes. So you have like 10 tables that you've loaded from Power Query to Power BI. It tells you how many percentage each of those tables is taken from your old model size. Then cardinality is like the number of your rows. How many rows do you have, and how does it impact your report majorly? Is there some things that you need to reduce? Is there something that you need to take away like that? Then on use columns too, it's also helpful to know, okay, which columns are you not using in the, this report, you built this, but in essence of building all this, you're not even using some particular columns at all. So what's the essence of bringing them in? So VertiPaq Analyzer just helps you to note all these things and then optimize your report in a better way. So let me just move to Power BI, then we can discuss one of the few things that I've discussed earlier. So this is a report. Presently, this report is about 400, and I actually tried to get at least a report that is a little bit big in size. I've done one report that I'm having about 2-point-something gig, right? And some are even like 4 gigs, 10 gigs. But I couldn't even get a hold because a lot of adjustments have been done that I will just check those reports, and when I see that it is this, I break it down and optimize my report. So majorly it's kind of difficult for me to even get a big and huge size report for this. So I got this RFM report, right? And the first thing is for me to check my performance analyzer. And we come to optimize, right? You see your performance analyzer, you can click on it. Then you can start recording. So if I click on start recording now, I need to do some things. Maybe refresh my visuals, refresh my report, click on the filter, and let me see how many minutes it take for that to load. So let me start recording now and go to some pages. You see how this one is loading, but thank God it didn't even take too much of time. So I will just check through like that, try to filter for something. It can be anything. It's already recording all those things. So when your report is done, before pushing it to the users, you just try to do some little things like that. Move from one page to another, filter something, see how long it's taking your visuals to load, and when you are done, you can click on stop. So now I'm done, and you see that all this, it's showing. You can also use this duration means and this small sort icon. When you click on it, it just want you to see, okay, let me sort by total time, and then in descending order, right? So you see the highest visual or interaction that is taking time to load, and you see around there that you're having 1161. This is 11. That's 1 second. Sometimes you see like 15,000 or something. That's 15 seconds or things like that. Because this is not too huge, but it's just like a display or a template of how it can look like when you're dealing with huge data set like this. And you see this 1,161 is the number of customers by number of accounts. When you click on it, it will surely show you the visual that you're on at that point in time. So from here, you can copy this query, and you can even run it in DAX query view. So thank God there's a DAX query view right now in Power BI. So when you just run this in DAX query view, it will bring you to the DAX query view, and then it will show you what you are loading, right? And here, this seconds, it just shows you the seconds that it has taken this visual to load. You can copy it and take it to external tools. And we have for external tools, we have the VertiPaq, what's it called? Sorry, Tabular Editor, you have DAX Studios, and then we also have the DAX query side in Power BI, which most people don't even use. We even shy away from it most of the time. But for the external tools I have here, I have Tabular Editor and DAX Studio. But for the Tabular Editor, you need to get a license. Sometimes they just give you 30 days, what's it called? Free trial. And when you are done, you can no longer use it. Yes. So I will just make it to a DAX Studio to check our VertiPaq Analyzer, and which I said that VertiPaq Analyzer will just help us to check the S status of this whole report and the data model at large. So if I click on this DAX Studio, because I'm currently running a report, I currently have a report here, it will just tell me to, okay, evaluate some table measures, and you can, the measures that the query that you've already copied, you can paste it in here, and then you start checking it through it, but I do not want that. So for here, the first thing is to clear your cache. Because cache, so there's something we call storage engine and formula engine, right? And storage engine, I'm thinking of way to explain the storage engine and formula engine so we can understand. All these things that we are doing in Power BI, there is something that is helping us to do all this work that we're doing, right? And those two helper is the storage engine and the formula engine. Let me explain it like this, okay? Because when I was also trying to get it then, it's kind of difficult. But a scenario, like you want to get something, right? You want to get like apples, banana, you want to get fruit, things like that from the supermarket. So you went to the supermarket, you want to get it, right? And from your own head that you want to get, you want the variety of fruit. Maybe I want the green apple, I want the red apple, I want this apple. You need to let somebody know in the supermarket, please, I need this, I need that. That person you're actually telling is a formula engine, is the master planner, right? They are the logic, the guy is a logic one, is a logic planner in Power BI. So all the DAX measures that you are writing and say calculate if this is this, switch and true, blah, 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 all those complex measures is actually the formula engine that you are telling first that, okay, this is what I want. Then the formula engine now takes it to the storage engine. The storage engine, our user wants fruits, wants apple, wants banana, wants this, and this is the kind of color this user wants. Storage engine, its own is just it's just like line manager and line report. Line manager, they give line manager projects, right, from EMC. Line manager thinks through it. They say, okay, this is how we can go about it. This is the best way we can go about it and the likes. But they give it to the line report. You don't even need to think too much. Formula engine has done everything for you. Just go to the store, get this, get that. So the storage engine just goes to the rack or your table or your data source, wherever it is, gets everything you want. However, it doesn't just go, like you have like 10 requests that you are sending storage engine. Storage engine doesn't go there one, come back again, go there twice, come back again, no. Storage engine will surely has other, how do I say it, helper that are helping it too. So at the same time, they move to the storage rack or where your data source is, get everything they want, and then take it back to formula engine. The formula engine will be the one to arrange it again the way he wants. Like, okay, you want it by, maybe you have a fruit, you want the red to be this, you want the yellow, number of red apple, number of green apple. So formula engine tries to process it again and then take it to the user, and that is what we are seeing at the front end. So storage engine is just like help, how do I say it? How do I put that kind of thing? You know, you have the like a Scrum planner or a master planner, and then you are having laborers, let me put it like that, laborers that is helping you to get the stuff. Storage engine makes it very slow. It's much faster rather than formula engine, because formula engine needs to process a lot of stuff before it gives you that stuff. But storage engine doesn't need to process, so it doesn't take too much of time for storage engine to get those stuffs and give it back to the formula engine. I don't know if you get it. Eh? Are we getting it? So, and the reason why for storage engine is much faster is because it processes our data. You know, in our own data set, we always have it in a row, in a row basis. Like you have your table and row, what's it called? Table and column, the way it is structured in Excel. But in storage engine, it is in column. It checks it in columnar view. So what you are seeing at the front end of Power BI is different from what Power BI is processing at the back end. Power BI changes it, all the reports that you are, all the tables that are like this, Power BI changes it in form of a like dictionary. I don't know, people that are data scientists say how their data dictionary, their dictionary looks like. So it takes it in a columnar way, which is much easier if you want to calculate sum of something. You just go to the particular column and then calculate the sum like this, rather than row by row basis that we usually do normally. So that is why it is much easier for storage engine to process things and get the results, because it also catches data, right? And it's just go directly. But all those complex formula that we are not talking about is a formula engine. So why sometimes it is important for us to ensure that storage engine is much faster, right, Then Formula NG is kind of slow sometimes, which I'm going to show in our VertiPack analyzer now. So from the advanced now, if I click on view metrics, right? View metrics will just help you to understand your data set. And if you notice something here, this local date table, because I said earlier that if you're not having a date table, you just check all the date time columns that you're having in your data set throughout and give it a table, this one table, that one table. And that is why it is, you see this cardinality, which is the number of rows, 2,836. So if you are getting rid, from here, in essence, you can even see overview of what you can actually do to ensure that, let me show you our results, sorry. From our summary, you see that we are having 424 MB. So the total size in memory is 424 MB, but this 424 can actually be reduced, because if you're trying to optimize it, then we look at our tables, right? All this local dates table that you're having, local dates. If we go back to our Power Query, right, and ensure that all the date time columns that are there, we change it to only date, this, date. Then we create a calendar table and we mark as date table, right? As calendar table. Map it in our what's it called? Our data model. All these local dates table that you're seeing here, they will be out. And then it reduces from that 420 something MB, bring it down to 200 and something MB, and like that. It just helps you to optimize your data model and then make it much faster. Also, this one shows you the column that is taking the much of your space. So if I scroll to my right, it shows you that this is 95%, 95.48% of the table. See that it is actually high, and in essence, we don't even need it. Let's look at this table. So if we can fix this local dates table issue first, it will help us to optimize our data size, right? And then it helps us to just get the actual data sets and data models that we want in our data. Then the other thing is what we call the best performance analyzer. Best performance analyzer, it's also like VertiPack analyzer though. It just tells you how you can improve. It tells you the, how do I say, the warnings, it gives you warnings. Like this, I scanned through your whole data, I scanned through your whole report, and I noticed that you can actually make some adjustments here. So there are 5 aspects or 4 aspects in best practice analyzer that just helps you to check and see, okay, in terms of performance, you're not doing well in this. In terms of formatting, maybe how your data is formatted, you're not doing very fine in this. It will tell you those warnings that you can go to this and do this. You can try to do that. Then also in error prevention. So it has formatting, performance, error prevention, and then maintenance. Those 4 or 5 aspects of key performance analyzer. And thank God to Power BI now, to Microsoft. Microsoft has actually included BPA or service. Before it wasn't there. I guess it was recent, right, Francis? It was recent. So we can, if you publish this report now to the Power BI service, if you don't want to make use of, Tabular Editor, because it's not free, right? We can load the table and load the data report, right? Publish it to the service. And then from service, you just go to your data view, and then you'll be able to query the performance analyzer there. So let me just do 1 or 2 things here. Okay, before I do this, let me try to publish it, and then we go to performance analyzer in Power BI service. Sorry, I need to get. So I've published this report to Power BI service, and from my service, rather than using Tabular Editor, I want to see what it will look like on service 2, right? I go to my report. This is the report, RFM segmentation. Then from the data semantic model, this is a semantic model. I just right-click, and then I try to open data model. So if you click on your open data model, right? Okay. From this top, you see best performance analyzer. best performance analyzer, by clicking on it, it tells you, as I've said earlier, the status or the health status of your data model. So I'm clicking on this now to see how practice analyzer, BPA, is doing, how it will detect a lot of stuff on our data model. So it's initializing at the moment, and at that point, it's just like creating a notebook because he's using code, Python, because you have to bring in, import some libraries, right, that will help you to, sorry, let's just skip to. So from here, you can see low-code solutions for this best practice analyzer, and you have to import some libraries. However, there's no even need for you to try to think of what library am I going to use to check the status of this data model. Microsoft has already included the code for us, so you don't need to go anywhere. It's just for you to run all the code, but I just want us to check how this code is. It's actually checking the version of a metadata library first, just to ensure that the version is up to date, number one. So if it's not up to date, it will tell you that you should install, pip install this, but if it's up to date, then fine and good, right? Then from here, it's importing another library, which is senpai.fabric, right? And from there, you have to notify your data set. What's your data set from Power BI that you've published? The name of the data set is this, and then the name of my workspace that the data set is published is this. So when this is done, the third one is to now run the best practice analyzer on the model. And let's see the miracle that Microsoft has done for us here. So let me just run all. Connecting. Actually, I can use Tabular Editor to do this, but I just want to see, I want you to see the magic that Microsoft has done for us, rather than trying to pay Tabular Editor for licenses, right? So it's still the same thing that Tabular Editor will give you, that BPA in Microsoft will also give us. So it's just best for us to use this, right? Thanks to Microsoft. And this has loaded, this is loaded, this is loaded, and the best practice analyzer and a semantic model is now loading. And let's see the magic that is bringing out. So has anyone used Tabular Editor before? The BPA in Tabular Editor, and we see that. Okay, so the same thing you're going to get in Tabular Editor, that's the same thing you're getting here, right? So from here, if you notice that it's showing you three major things. As I've said, we have like 5 major aspects for the BPA. You have the formatting, maintenance, performance, error prevention, and there is another one that I cannot remember. So all those 5 aspects is just going to give you some warnings, number one, and then important notice. So this blue one is important notice, that it is important for you to notice 52 things in your formatting. And then warnings, there are 33 warnings that is giving you. That 33 warnings, go through it and ensure that, okay, you go back to your data set or your Power Query view, which we talked about, the 4 optimization view, that Power Query optimization, DAX optimization, reports view, and then the last one is what? Yeah? Data, DAX view. So those 4 things, so all these warnings that is giving you, it's now best for you to go to all those aspects that we've talked about and then see how you can make adjustment or changes based on each points that I've mentioned earlier under them. So let's come to formatting. You can click on it, then to only show you that you're viewing for formatting. And for formatting, you see object name, right, which are the column names. Object name are the column names. And it's telling the severity, which is just warning, right? It's telling you that for this particular column, average balance, do not summarize numeric column, right? Do not, you just see that for all the columns that are numeric, it will tell you do not summarize numeric column, do not summarize numeric column. So it's left for you to know, okay, what am I supposed to do on this column? Is it the data types that I'm having problem with, or I need to go and adjust the data type from Power Query, right? Then the other one these are important notices actually. It's saying first letter of object must be, it's just formatting, we don't need this. It's just formatting. My first letter of my object be, must it be capitalized? No. So you move down and say, this is also saying hide foreign keys. Is it necessary for you to hide foreign keys? This is saying mark primary keys. And then when you come to dates, it's saying provide format string for your date columns. You see the problem we're talking about. So when we check Dark Studio, we notice that the issue that we mentioned under the date time columns is still the same thing that best practice analyzer is also telling us here. So you should know by then that, oh no, I am having a problem with all my date feed in my data set. So for you to go back to it and then create a calendar table, change it from date time to only dates if you do not need the time, then mark it as date calendar table and join those two data sets together. Do we get? So let me go to the performance aspect. So if you click on performance, there are 68 warnings on performance, and it's just saying avoid using calculated columns. You know, we discussed about this in report, what's it called, index view, right? So you just avoid all those things, avoid using calculated columns. If it's something you can push back to Power Query or to the main source, then we do that. Then date calendar, you see, it's saying date calendar should be marked as a date table, which is one of the things we also discussed. Do not using floating data type. So my best practice analyzer just helps you to, it tells you actually what to do. That this is what you're meant to do. This is what you're meant to do for you to reduce your data size, optimize your report, makes your reports to load faster, refreshes your reports on time and the like. So all these things, when they are put into consideration, you are good to go. I'm telling you. Because I've done it several times. I have a data of 1-point-something gig and I reduce it up to like 300 MB. So with all these things that is just giving you idea of this is what you should do, this is what you shouldn't do. So all these date table templates, look at this table. It takes sizes. Don't let me deceive you. So if you ensure that all these things are taken care of in your data, from Power Query to your data view, then you are good to go. So thank you so much for having me.
Thank you very much, Adebola. I'm sure that was a very loaded session, right? Yes. How many did you hear for the first time today? Storage engine, formula engine, tabular editor, BPA. The idea is for you to get as much information as possible, and then you go back and then look at the things that you don't know. Now, I was aware there is BP Analyzer and Power BI service, but I have not tried it out. But now that she has used it, I have tried it out. And I'm sure that some people will go back up to their place of work on Monday and then they will try and do some best performance analyzer. It's just a set of rules, right? Mm-hmm. At the back of my mind, as she was taking us through the session, the only thing that was on my head was this book by this DAX guy, Mark Russo, Definitive Guide for DAX, and then best modeling, best performance, what can I say? Best practice when it comes to modeling, right? When you are developing, the first thing I want to do is that, okay, I want to remove auto dictate of this, I'm marking my list table, I'm moving unnecessary column, I'm not summarizing, I'm not supposed to. So these are some of the things that you need to do and make sure that, okay, you have the best performance. And optimization is actually a very big deal, right? Many people develop reports without factoring performance. Mm-hmm. It's at the point of consumption that they will not come back that, oh, you are trying to optimize this and that. And from what we were talking about last week, when you go on Upwork, you see that, okay, we want to optimize this report. We have this report, we want to redesign it and optimize it better. These are some of the things that you can actually do from scratch as you are developing your reports to make sure that your report is well optimized. Optimization starts from the point of where you connect to your data. For as far back as you doing your query folding, right? To you taking all the columns that are not. So don't let me just go through it all over again. Thanks so much, Adebola. It was very insightful session.